this is going to be a long video, and this video is going to cover separating mixtures, the whole topic of separating mixtures. So it is very important for you to be able to watch the full video for you to understand how different mixtures can be separated. So to begin with, before we separate any mixture, what we should understand is there are various separation methods, but for us to choose the most suitable separating method, we must understand the properties of the elements that came together and formed the mixture. Is it a compound? Is it a mixture? What it is. So that will help us to know which is the most appropriate method to separate the mixture. So first of all, we are going to discuss about simple mixtures. So let us say water and sand mixed together. How can we separate water and sand? So we all know that sand is a heavy, clean stone. So we can use a method called decanting to do the separation. So decanting is a method where we simply pour the mixture into a beaker, and then we all know that sand is heavier than water, so sand is going to settle at the bottom. Therefore, we can simply pour out the water and then the sand remains. So this method of separation is called decanting. Now, we have got a second scenario where we could be having water mixed with mud. So let us take away sand and we say this becomes mud. So we all know that the mixture of water and mud is soil. It is insoluble in water. But however, mud is made up of clay. The kind of soil, it is clay soil. So clay soil, when it mixes with water, you cannot use the decanting method because clay soil is so fine to an extent that much of it will float in water. Now, this method we can use a separation funnel or a separation paper. It takes longer though. So we simply pour the mixture into a separation funnel. We simply pour the mixture into a funnel. So this is the funnel. And we leave the mixture. So at the end of the funnel, there are sort of bigger particles of soil. So what will happen is our water will slowly drip out and collect into a beaker, while our clay soil will remain in the funnel. So this is the most appropriate separation method if we are to separate water from clay soil. Now we move to the next separation method, which is called evaporation. So in this method of evaporation, we will be separating, for example, copper sulfate solution from water. So copper sulfate dissolves in water, but the two do not chemically bond, but copper sulfate completely dissolves in water, in as much as salt dissolves in water. So to separate this kind of a mixture, we simply take the mixture in the beaker and we apply fire. We will evaporate all the water. All the water will boil out of the the solution. And as the water boils out of the solution, the copper sulfate crystals will remain because they've got a higher boiling point. An open flame like this one will not be able to boil the copper sulfate solution. So the copper sulfate crystals will remain in the beaker while the water will be boiled out of the beaker. So this method of separation is called evaporation. We go on to look at the next method of separation, which is called distillation. What is interesting in this method of separation, distillation, it uses the same principle like evaporation. The same principle applies with distillation. But however, the main difference between the two is that in distillation, we need both the liquid as well as what dissolved in the liquid. So we need both the solvent and the solute. So let's say, for example, we want to purify seawater. We want to separate the salt from the water in the sea. So we will use distillation. Now, in distillation, we pour the solution into the distillation apparatus and we apply a flame. What will happen is, as the solution absorbs heat, it will start to boil. The water will boil out and be collected in the beaker. So this is our water that is collected at the end of the distillation apparatus. And the salt will remain crystallized in that distillation apparatus. So in distillation, it is also important to notice that as the water is evaporated, it will be collected into the distillation channel. Until this point, it will still be in form of vapor or steam. And then there is an independent apparatus attached to the distillation funnel. And this independent apparatus, cold water is pumped into it and it will be circulating and it is taken out at that point. So this cold water will cause this vapor to condense, and it is in here that it starts to be liquid from a gas state. From this point coming in here, the water is in gas state and it is condensed in this apparatus, in the condenser. So the water will be condensed and it goes back to becoming liquid and it is collected in that beaker there. And then we have pure water and we have pure sodium chloride, which is salt. So this is distillation. However, there is also an advanced type of distillation. And this advanced type of distillation is called fractional distillation. Okay. And we are going to remove salt there. Now, in fractional distillation is used to separate what we call miscible fluids. Fractional distillation is used to separate what we call miscible fluids. Miscible fluids are miscible liquids are liquids that dissolve completely in each other. An example is ethanol and water. Ethanol and water. Ethanol and water is an example of a miscible liquid. So, the reason why they dissolve completely into each other, it is because of their properties. For example, they have an almost similar density. That is one example. Now, it is impossible for us to use other methods except fractional distillation. So, we want to separate ethanol from water. So, when we look at the name fractional distillation, let us define what fractional distillation is. Let's look at the word fractional. Fractional means in stages, in other words. So the stages that they are talking about here are the boiling point. Those are the stages that they are talking about. So in this method of separation, we take advantage of the different boiling points. Right. So ethanol will boil at about 78 degrees Celsius and water will boil at about 100 degrees Celsius. So these two, they have got similar densities and these two have got similar other properties. But however, they have got different boiling points. So we take advantage of the different boiling points to separate them. So what will happen is we apply a flame to the fractional distillation apparatus. And as the solution of ethanol and water absorb the heat, at 78 degrees, when we reach 78 degrees, ethanol will change from a liquid into gas. And it starts to boil out of the solution. So as ethanol boils out of the solution, it changes into a gas form. And because at the top there it is closed, the easy way out will be to follow this channel. And as it reaches the condensation apparatus, it is turned back into liquid. It is condensed into liquid, and we will collect our ethanol at that end. What is important is when we reach 78 degrees Celsius, we must maintain the temperature of 78 degrees Celsius because we don't want to reach the boiling point of water before we have collected all our ethanol. If we make a mistake, for example, and we reach the temperature of 100 degrees Celsius before our ethanol is totally boiled out, what will happen is ethanol and water will all boil and we will collect it in the collection beaker, which is not what we want. What we want is to separate the two liquids into their pure substances. So we must maintain the temperature of 78 degrees Celsius until a point where ethanol ceases to boil. That point when ethanol ceases to boil, we will know that all the ethanol has been collected in the beaker. And then at that point, we take off the beaker, we put another one, we increase the fire, which will increase the temperature until 100 degrees Celsius. And at 100 degrees Celsius, our water will begin to boil. And our water, when it boils out and finishes, will have collected our water. So that is fractional distillation. Now, the same principle or the same method of fractional distillation. It is the one that is used in the manufacture of diesel and petrol. We must remember that diesel and petrol are crude oil fuels. So, crude oil is a type of a fuel that is mined from the sea. Now, crude oil, so at this point, this is the diagram that we are talking about. So the separation of petrol and diesel from crude oil is called fractionating column. So this is our fractionating column. So what they do is, crude oil is heated to a temperature of 450 degrees, and it is at the temperature of 450 degrees Celsius. It is then injected into the fractionating column. So this whole thing is what is called the fractionating column. So in the fractionating column, the crude oil is pumped in at 450 degrees Celsius. So at 450 degrees Celsius, the crude oil will be in form of gas. So in this fractionating column, temperatures are lowered. In other words, this fractionating column is a cooling system which gradually lowers temperatures. So diesel will be collected at 250 degrees, and at about 25 degrees petrol is collected. So at 250 degrees, this is diesel, and at 25 degrees and less, this is petrol. But let's discuss the reasons why the two are collected at different temperatures. The reasons why the two are collected at different temperatures, we simply go back to the elements that make up diesel and petrol molecules. So what we must understand is that both diesel and petrol, they are made from hydrogen and carbon atoms. The molecules of diesel and petrol are made up of hydrogen and carbon atoms. However, in diesel, the molecules of diesel contain 14 to 19 carbon atoms, and the molecules of petrol contain 5 to 10 carbon atoms. Now, based on these two facts, diesel is heavier than petrol because this one contains 14 to 19 carbon atoms, and petrol molecules will contain about 5 to 10 carbon atoms. So the density of diesel is more than the density of petrol. So since the density of diesel is more than the density of petrol, it means that diesel has got a tendency of turning into liquid at the lower level because it is heavier. Petrol will have the tendency of turning at a higher altitude because it is lighter. So in the fractionating column, they are able to collect diesel first at the lower level because it is much heavier, and they are able to collect petrol at a higher altitude because the molecules of petrol, or the density of petrol, is less than the density of diesel. So this is what happens in a fractionating column. So a fractionating column works in the same principle with fractional distillation, but this is more of an industrial process of fractional distillation. Fractional distillation, we can do it in a laboratory, but we will not be able to do a fractionating column in our laboratory at school. Okay, now let's look at the sixth type of separating mixtures. We spoke about miscible liquids, which is ethanol and water. However, there are some liquids which are said to be immiscible. Immiscible liquids are liquids that can mix but in their tiny particles. So they do not dissolve in each other. When you look at them with the naked eye, you can be able to tell that this particular droplet is different from the other. A good example is oil and water. When you mix oil and water, they will mix in droplets. They will not dissolve in each other. One of the major reasons why oil and water will not dissolve in each other, it is because of its properties. It has got very different densities. So to separate the two, we use what we call a separation funnel. A separation funnel looks like an ordinary funnel, but however, it has got so this is a separation funnel, and here we will have our collection beaker. So the mixture of the two or more fluids is poured into the separation funnel, and it is left to stand for days. What will happen is the liquid that has got the highest density will have a tendency of settling at the bottom, followed by the liquid which is averagely dense. It will settle there, and the least dense liquid will settle at the top. And then when we achieve this, we open the valve, and the heaviest or the most dense liquid will come out first. We close the valve when we finish collecting the most dense liquid. We take the beaker away, we collect the averagely dense liquid, we open the valve, collect it, take it away until we reach to the least dense liquid. So the most important points to remember is that the properties of the substances that are mixed together are the ones that guide us in choosing the most appropriate separation method. So this video covers the whole topic of separating mixtures. So remember, as scientists, you must always be curious. You must not stop digging for information. A scientist keeps on researching and getting more information, and even setting apparatus at home to find out more information.